Alright, I am re-recording this video because for some reason the audio on the first one got so messed up and I have no idea why, so I'm hoping that this one is going to be okay. Um, Alright, okay, so with that said here, just really quickly, I'm going to go through, going to take 22 minutes, no more than 22 minutes and 30 seconds because this is how much time we would have to do an FRQ on the exam. Okay, we've seen this problem before. This single table and combined table class situation here, right? And so we need to go ahead and write the class here for this, this right here. We need to write this class, combined table. All right, and so there's a lot of information right here, and there's a lot of information right here, and sometimes it can take a little bit of time for the brain to process everything here. One thing I like to do is I like to first look at the chart. Like this information, I do need to go back to it, but I want to go and look at the chart first to kind of glean what needs to be done first. Now, first off, I know that every FRQ is going to have about 9 points. Not about, 9 points. I can get 1 point just by writing the name of the class and properly writing the constructor. So I'm going to go ahead and I know I need to write this class. It's called public class combined table. Okay. And all right, so that's all good. And let me just go ahead and let's put this in a nice little font here. There we go. Okay, and make it look, yeah, they're good. I know get one point for writing the class header and then the constructor. So I'm going to go ahead and write the constructor. I will need to write my instance variables. The instance variables will come before the constructor, like right around here. But it's helpful for me to just go ahead and write my constructor since this is also the first thing that comes up. So for my constructor, I know that my constructor is always public, doesn't have a return type, and the name of the constructor should always be the same as the name of the class. So I'm going to go ahead and say that. I need to always write parentheses whenever I am writing the header of a method or calling a method. And I can determine what parameters this constructor needs based off of the values that are used as input to this constructor. So T1 and T2 are, it says, a combined table is composed of two single table objects. Okay, so T1 is a single table, T2, T3, okay, and then they've got a bunch of information. So I can go ahead and write that in my header. I'm going to say single table, T1, single table, T2. Now, please do not confuse these parameter names with these single table objects up here. T1 and T2 is just the temporary name that I'm giving to any tables that are being given as input to this constructor. So it's basically, I guess, one way to put it is that even though I'm saying T1 and T2, it's not necessarily the same T1 and T2 as is right here. Okay, perfect. So now what I need to do is, I know that these are my two values that I have as input. So that tells me that at the very least, I'm going to have two constructors. One for the single table, first single table. I'm going to call it table 1. One for the other table. I'm going to call it table 2. I could have also called them T1 and T2, but now we've got a whole bunch of variables with the same name, so let's kind of avoid that. I'm going to say table 1 gets T1. The equal sign here, this assignment statement, is pronounced gets, so that's why I said gets. Okay, table 2 gets T2. Great. Now I'm done, okay? Remember that these two values, these two parameters, T1 and T2, can only be used within the context of this constructor because these are local variables. Or these are variables with method level scope. These instance variables, table 1 and table 2, I can use them anywhere in my code, anywhere within this class. But these T1 and T2, they can only be used within the method. So the basic way to think about it is like, if the variable, sorry, I'm laughing because I thought of a different version, but of what I was going to say. But these two variables, it's like if you create a variable within a method, it stays in the method. If you create a variable within a class, it stays in the class. These methods and the methods that I'm about to write are still part of the class, so I can still go ahead and use my variables table 1 and table 2. Now I'm going to go ahead and write my methods, because that's the third part. The first part is instance variables, the second part is constructor, and the third part is always the methods here. And that's just standard. Usually people don't really mix it up and put the constructor first, then the instance variables, then the methods. They usually stick to this format. Okay, keeps it nice and clean. So now the methods. So I see two methods that C1 is using, can see and get desirability. Set view quality is also a method that's being called, but it's only being called on its table objects. So this doesn't tell me that a combined table has a set view quality method. So let's go ahead and write my method headers. The first thing I'm going to do is I'm going to say public, and let's see what data type can seat returns. False. So it's returns a boolean. Public boolean can seat. Great. And then I'm going to go ahead and figure out what the input. Aha, it's an integer. So I'm going to say int, and I need to figure out a good name for this integer. I mean, I could call it anything like x or n, but sometimes that does get you into trouble. If you have called your variable something that it doesn't really represent, then later on you can be running under the assumption, like for instance, if I called this int count, I would be running under the assumption that this represents some sort of count, but it doesn't. It represents the number of seats. Cannot seat 11 people. Seats needed. Okay. Having good variable names does help to make your life a lot easier here. Okay, first thing I'm going to do, since it has a Boolean return type, I'm going to go ahead and create a variable and say something like, Boolean result gets, and let's say it's false right now, and then return result. I may end up deleting this line of code, but it's just a reminder to me to make sure that I return the correct data type. And then there's another method, and it's called get desirability, and I'm going to say public. I'm going to figure out what data type get desirability returns. It returns a double because I see this decimal right here. So I'm going to say double get desirability. And does it take anything as input? No, it does not. So I can go ahead, and I always need these parentheses, but I'm going to leave them blank. Okay, the parentheses kind of indicates, the parentheses is an indication that I'm not creating, basically if I don't write the parentheses right here, I guess one way to think about it is that how does Java know whether or not I'm creating an instance variable or a method? I mean, it's technically possible to create a public instance variable, it's just not a great idea. Okay, so the parentheses is like a little signal to say like, hey, this is a method. It's a set of code that we can reuse, not a variable storing a value. Although a method may contain variables, it is not itself a variable. It's just a set of code that performs some task. And it may or may not use variables. Great. Okay, so now, So now I need to also, so I've got the header. I know it returns a double, so I'm going to say int result. Oh no, I keep saying int. Double result. I want to make sure that the variable that I created up at the top is the same as the data type of the return type here. So I'm going to say return result. Okay, there we go. Good. Sorry, it keeps automatically capitalizing my text, which is not helpful in this case, but that's okay. So now, this right here would probably get me a good 5 points, right? This is without me having read anything up here. All I'm doing is using the data that is given over here to get a better sense of what the, I'm using this data to create the overall outline, the overall shell here of this problem. Okay, let's go ahead and see if we can write can see. Okay, so can see. Okay, so it says, all right, so this is a class, a single table class. Okay, so this tells me what my little table objects, my little instance variables are here. This right here, this class, these methods tell me what that object can do. That object can get its height. That object can get its number of seats. That object can get its view quality. It can get its set quality, all of that. So, okay, so it says at this restaurant, customers can sit, and again, I had no context on what this problem was about at all. But even with just looking at this table, I was able to grab and find how I would get my points here. So it says, right, okay. At the restaurant, customers can sit at tables that are composed of two single tables pushed together. Okay, you will write a class combined table to represent the result of combining two single table objects based on the following rules in the examples in the chart that follows. Okay, so some context here for this problem is like, imagine like we are doing some sort of like seating arrangements at a fancy fine dining restaurant at the top of a building in New York City. So there's a really great view. We can see like, well, there's the potential to have a really great view if you're next to a window. You know, sometimes there might be a larger party. So we've got to take two tables and put them together. And that is kind of where this combined table comes into play. We take two individual tables, we put them side by side, and then we count the number of seats around the table in order to figure out the combined table number of seats. So it says a combined table can seat a number of customers that is two fewer. Okay, so now this is translation into an algebraic expression. Two fewer than the total number of seats in its two single objects to account for the seats lost when the tables are pushed together. Okay, so yes, when the tables are pushed together, that means that the people who would normally sit at the ends, they can't sit there anymore. The people who would sit at the ends when the table gets put together, those tables, those inner seats are lost. So we only have the seats around the perimeter. So, okay, two fewer than the total number of seats in the two single table objects. Okay, so when I see total, that gives me an indication that I need to do some adding. So what I'm going to do is I'm going to take table 1, not T1, because T1 only exists within here, and table 1 is the variable that actually holds all of my this is the instance variable, right? That has the table that I'm working with. So I'm going to say table1.get, and I have to figure out the number of seats. And yes, that's what the method's called, get num seats. Okay, and then I'm going to add the table2.get num seats. Good, okay. So it says a combined table can seat a number of customers that is two fewer than the total number of seats in its two. Okay, so if, this is where I'm going to need a conditional statement. It didn't say if, but if I've got a Boolean as my result, that kind of gives me an indication that I'm going to need an if statement. So if the seats needed is less than or equal to total minus 2, and maybe I need to put this in parentheses. Okay, so if that's true, then if that is it, then I can go ahead and make my result to be, I can update my result and make it to be true. Otherwise, I'm going to return the result, which is false. Okay, sorry, that was a very long sigh. Starting to think about this next piece. All right, okay. Right, okay, so then I guess can see is done. So if this doesn't return, so if this is not true, if the number of seats is not less than or equal to the total minus 2, if the total number of seats needed is not less than or equal to the total minus 2, then if this is not true, then we're going to skip this if statement and false will be returned because that's the only value it's been given. Otherwise, the result becomes true and we'll return true. Woohoo! Some would say you don't need this, which is true. I don't. I could actually delete it at this point. I could say delete and return false. I could do that, and that still works. I just like to create that variable up at the top to, like, it basically reminds me what I need to return. And it's very helpful. Like, you could always delete it at the end or cross it out. Don't erase on the AP exam, just cross out. because if they can see it, then they have to assume that you meant to keep it there. So just cross out to be clear. Right, so it does help you to get a good foundation for the problem, because if you know that you need to return an integer, then everything in your code should be working to return an integer. Sometimes I have students who the data type will say Boolean like this, and they'll return a string at the end, and my answer back is like, wait, no, that's not what the problem asks you to give back. It asks you to give back a string, not it asks you to give back a Boolean, not a string. So you want to make sure that whatever you're returning matches up with this. Okay, so now we have to do the desirability. Okay, so with the desirability, it says it depends on the views and the heights of the two single tables. Okay, so if the two single tables are the same height, the desirability of the combined table is the average of the view qualities of the two single tables. That's a lot of information. I'm going to just try to do this first part right now, so I don't forget. So it says if the two single tables of a combined table object are the same height. Okay, so let's say if. Okay, and I'm looking at the tables. I need to find out something, the height of the two tables, and I have this method, get height. So if the height is the same, and here I'm going to use this equality operator, because we use dot equals when we're comparing objects. Objects are strings. This right here, this combined table object. Basically anything that isn't an integer, a Boolean, and a double, for the purposes of the AP exam, it's an object. If it has methods, if it has instance variables, then we know that we're working with an object. So if these heights are the same, oh yeah, and if we're working with the object, we use dot equals. Otherwise, ints, doubles, booleans, any of the primitive data types, we're going to use this double equal sign. So if the height, oh, this is a 2. So if the height of one is the same as the other, and we are going to go ahead and we're going to return. You can say return, or what we could do is we could returning. We could go ahead and we can make the result to be same height. If the two single tables of a combined table object are the same height, the desirability of the combined table object is the average of the view qualities of the two single tables. And there is this get view quality method. Okay, so I'm going to take table 1 dot get view quality. We've got 4 minutes left. Plus table 2 dot get view quality. Okay, I'll put this in parentheses. Take these two. To find the average, I've got to add the two together and then divide by the number of numbers that there are. There's 2. Okay, so good, done. Okay, that's done. All right, so I got the view quality of the first one, the view quality of the second one, and I divided them. Woohoo! Great. I wonder if this formatting will be better. Maybe not. Okay, good. Exactly. Otherwise, if the heights are not the same, this is what we're going to do. We are going to go ahead and we're going to have something very similar. We're going to take the result and basically have the exact same code. You wouldn't be able to copy and paste like I'm doing on the AP exam, but this is just to show you as quickly as possible to minimize the length of this video, which is already 19 minutes, but it has to be because that's how long we need to do in our FRQ. But it says if the two single tables of a combined table object are not the same height, the desirability of the combined table object is 10 units less than the average of the view qualities of the two single tables. Okay, so it's like the same value minus 10. Okay, if I didn't want to write all this code so many times, what I could do is I could say like double average. I could create another variable up here and go ahead and create the average right away, and just go ahead, since I know for both of these problems I'm going to need the average, I could take this. Oh my goodness, I forgot the 2. That was so important. Okay, I could do this. Okay, and then if that was, so that way I just have to do it once, and I could say the result gets the average, because that's what this is. Or for this one, I could say average minus 10. I could shorten this even more. I technically don't even need this else statement, because if this is... oh, here, actually, no, I've got to be really careful about that. I was going to do something, and that was gonna cause a problem. You could do this without an else statement, but this only works without the else statement if you return up here. Because right now, otherwise, if I left it like this, if I did it like this, the problem is that both of these lines of code would run, and we want either or. So we need to make sure if we do it this way, where we take away the else statement, we have to say return result. So that way, only one of these two sections of code is ever going to run. So if they're the same, the result becomes the average, we return the result. And when we write return, like the rest of the code for the method is completely ignored. And then if this is not true, then obviously this gets ignored and it jumps down to this part right here. And the result becomes the average minus 10, and that gets returned. And so thus the problem is fixed, and we're done. And so I finished my class, I finished my methods, okay, and I returned the right value. Okay, here I return a Boolean. Okay, make sure you have a return statement for every possible path in your program. Like if I just kept this result equals true, and did like return, oh, here I have the same problem. Oh, I made a mistake here. Hopefully you see my mistake here. I need to make sure that I say return result as well here, because otherwise I would have had the same problem that I described down here, where it would have changed the result to be true, which is good, but then it would have jumped down here and returned false. So I have to make sure that, like, once I find basically what I'm saying here is, once you find your answer, go ahead and return. Don't forget to return, because if we don't return, the program is going to keep on moving here, okay? So that is it. That is the process for how we solve this FRQ. It's all about really, like, if you're really stuck, focusing on this right here, this chart, to go ahead and write your constructor, the headers of your method. And then from there, when they give you these instructions right here, you go back, you just spend some time like carefully reading what it's asking you. 2 fewer than the total. And you're like, okay, I know what a total is. 2 fewer means, okay, subtraction. We've got to find in this one, we had to find the number of seats. Well, hey, thank God, there's a nice little method right here called getNumSeats, right? And this other one here where it says, checks to see if they're the same height. Well, is there a method that can help us? Oh, okay, get height, right? So make sure you don't forget some of the tools that we've learned about. Like, for instance, if we call a method, we need to make sure that we say object.method and then arguments. Okay, we can delete this if we are calling a method within its own class. Like, for instance, what's a good example? Right. Okay. If for some reason I was calling get desirability within canSeat, well, these two methods are in the same combined table class, so I can just say get desirability. I don't need to write the name of the object in front of it. But for instance, up here for this single table class, right? If I for some reason wanted to call, and I wouldn't because it doesn't really make sense, but if I for some reason wanted to call get desirability within get height, the single table method, I would have to create a combined table object, and then use this process where I say object.method and then put the name, okay, or put the arguments. Okay? That's the process for how we using this formula. This is the process for how we use the code in another class. If we want to use the methods, which are like bundled sets of code, within another class, we have to use this format. Okay, I give you a lot of information here. Some of this might feel like a little bit of extra information here, but I also just wanted to address some of the problems that some of you might have run into. I know many of you might look at this and be like, oh, I wrote this a different way, and it's okay. You can write this problem in a different way. You just need to make sure that your problem is logically equivalent. Your answer is logically equivalent to what the College Board instructions are, okay? Hope this helps, and have a great day.